Okay, recording. Okay, so let's just go through some partial fractions, but the case where the denominator is non-factorizable. I'll just work with proper fractions all the way. So we don't have to work with, we don't need to do long division. I'm sure you know how to do long division by now.
I hope so.
Yeah, should be. Denominator non-factorizable. So let's go through some examples. So the classic example of non-factorizable quadratic would be something like, let's just make my life easy. I'll just choose a constant 2. And then I have something like, here there's a what do you call it? Distinct linear factor. Linear means power 1. And then here you got a x squared plus 5. Okay, maybe I make it 9. Oh, perfect square. Here, what do you notice? X squared plus 9 is a quadratic, right? Power 2. Yes. But what's missing? Usually quadratic, the full form will be something x squared plus something x plus c, some constant, right? But here there's no x term. What else do you notice? It's a plus sign. Okay. Whenever you see this form, in general, x squared plus k squared, k can be any constant. It will be non-factorizable. Okay, non-factorizable. Actually, you can factorize if you know about complex numbers, so it will become something like minus ki and plus ki. But you really don't need to know this. Not for now. Okay. Yeah, don't learn about complex numbers yet. No. Okay. So it's just non-factorizable. That's the first form. But there are other forms of non-factorizable quadratic, such as the case where you got, it's still ax squared plus bx plus c. But sorry, I shouldn't put an equal sign. But the b squared minus 4ac is less than 0. When you have that, what happens? You cannot get real roots. Then therefore cannot factorize. Okay, you can check. This one x squared plus k squared is really just the same as 1x squared plus 0x plus k squared, which means that your discriminant will be what? 0 squared minus 4 times 1 times k squared, which is negative 4k squared, which will always be less than 0. Right? So that's the general reason. Whenever b squared minus 4ac is less than 0, then it will be non-factorizable quadratic. But this is the classic form. Usually no linear term, and it's a plus sign over here. Guaranteed you will have a non-factorizable. So let's just do it. How do we factorize this? First, you must identify the distinct linear factor. As usual, must have a 1 degree less, so a constant on top, then x plus 1. Then you add on here, non-factorizable quadratic. So you cannot factorize, just copy and paste x squared plus 9. But the numerator, what should it be? 1 degree less. Always remember, minus 1 degree, minus 1 to the degree. So minus 1 to the degree, what will you get? You get linear. So it must be something x plus a constant. Since I already used A, the next letter must be B, then C. Okay? This part okay? So now you can expand. So if I expand this, I will get 2 equals to A times x squared plus 9. Plus, I think by now you do until you're very bored already. So many practice questions. Oh, you get the pattern. But here, what I notice is that you always try to expand everything out, then you compare coefficient. I am very impressed by your algebra. Very good. But there's the smarter way, which is to sub x. Choose. Then it will be easier. But your algebra is very strong, so you didn't make any mistakes. Most of them. But anyways, this one you can just expand. Yeah. Why is that face? Okay, here I multiply the x by a -1, then -b, but it doesn't matter because at the end of the day, x plus 1 sub in with -1 goes on. -1 plus 0 becomes a 0. 0 times anything? 0. Just becomes a 0. Then you can just ignore it. So I'm just gonna clean this up as a 0. Or I don't even have to write it if I'm fast enough. Okay, maybe I'll just strike it off. Okay, and then therefore I get 10a equals to 2, which implies a equals to 2 over 10, which is 1/5. Okay, and how about b and c? That's when you to pick other strategic values. Can you make x squared plus 9 equal to 0 or not?
No.
Look at the graph of x squared plus 9, it's always floating on top. It passes through 0, 9. So it's impossible, exactly. You can never have x squared plus 9 to become 0. So that's why just pick any other random values. I like to pick 0 because it makes my life easy. 2 equals to a times 0 squared plus 9. Oh, wait, sorry. I already know what's a. So I should replace a with 1/5 straight away. Then 0 squared, which is 0 plus 9, just 9. Add on 0 times b is 0 plus c. Okay, maybe I just write this down, 0 plus c to make it extra clear. Then 0 plus 1. And simplifying, I get 2 equals 9 over 5 plus c, which means that c is equal to 2 minus 9 over 5. That would be negative 4/5, right? Is it?
Yeah.
Yeah. 8 times 5. Or is it 1/5? Wait, sorry. Wait. Hold on. No, I think it's just 1/5, right?
Yeah.
Sorry. Yeah, 1/5. Okay, good. So I managed to solve for C. Now how to solve for B? Remember you got A and you got C. So you must substitute in A, substitute in C. Then you just pick another random value of X.
1.
1. Just make sure it's different. Yeah. Then the 2, because I chose 2, so my life is easy. I just have to write down 2. I don't need to sub in the X. But if this was something else, like for example, if this was like 2x, then I have to 2 times -1, 2 times 0, 2 times +1. The x must be substituted both in the left as well as the right. It's just that over here on the left-hand side, it happens to just be a 2, so I don't need to do anything. I purposely chose a simpler example. Then yeah, just sub in. So a times 1 squared plus 9, which is 10, plus b times 1, plus c, we already know is 1/5. Multiply by 1 plus 1, which is 2. Multiply out, oh sorry, I forgot to replace the a with 1/5. That gives me a 2 plus 2b plus 2 over 5. Then I'll get 0 equals 2b plus 2 over 5. Bring that over, I'll get 2b equals -2 over 5. So b equals to -1 over 5. Okay, and conclusion will be, what's my a, what's my b, what's my c? It's here, here, and here. So therefore, conclusion is this fraction, I just copy it down, but I replace my a, b, c with whatever I found. So let's just do that. A is 1 over 5, B is -1 over 5, C is +1 over 5. Okay? Yeah. Then you can clean this up a little bit. You can also rewrite it as 1 over 5 times x plus 1. You don't need to do this if you don't want to. -1x plus 1 over 5 times x squared plus 9. Here, -1x, you don't actually need to write the 1. Yeah, then these are both the same. This is optional. Okay? Yeah. So that is for one example. Do you want more examples?
I'm okay with anything.
Okay, then I'll give one more. But this time I'll just check that b squared minus 4ac is less than 0, and it includes a linear term. So let's say I have another example. I don't know, 2x. Then at the denominator, I put down x squared plus x minus, let me calculate first. B squared minus 4 times a times c. I better make sure this is positive. Maybe I will make sure this is a bit bigger. So how about 5? Let's check. Is this a proper fraction?
Yes.
Yes, because numerator degree 1, denominator degree
2.
So it's proper. Okay, then can we factorize this? Every time you see quadratic, you should try to factorize. But let's just check b squared minus 4ac. You realize that it becomes 1 minus 20, which is -19 less than 0, implying that it's cannot factorize, non-factorizable, cannot factorize. So straight away, you just go for the partial fractions already. And then you realize, actually, since this is non-factorizable, the numerator must be what? Ax plus b, 1 degree less, right? Then x squared plus x minus plus 5. Then Is there anything else?
Mm, no.
No, there isn't. Which means that this one is already done. You don't need to what do you call it? Partial factorize.
Wow.
You don't need to, because over here, this is just one single factor already. Whenever the denominator only has one single factor, you're done. Don't need. A is
Okay.
just equal to 2, B is equal to 0. Oh, you just get 2x. Okay. So maybe this is not a good example. I just want to highlight to you that sometimes you don't need to. Sometimes you don't need to prime factorize. So maybe it's better if I just introduce one extra factor, let's say x minus 1. Then that's when you really need to prime factorize. So a over x minus 1 plus bx plus c over x squared plus x plus 5. Is this part clear? 1 degree less, 1 degree less?
Yeah.
Okay, then
Yes.
after that, just multiply. Okay, so you get 2x equals to a times x squared plus x plus 5 plus bx plus c times x minus 1. Can?
Mm.
Okay, what value of x would you want to pick? So,
Big X equals to 1.
okay, can.
Then you get rid of the
Sorry.
right side.
Yes. So the right side, because of the x equal to 1, x minus 1 becomes a 0, which means that you get a 0. Then, oh, sorry, here, be careful. When you sub x equal to 1, the 2x on the left-hand side will now become 2 times 1, which is just 2. Yeah, then substituting the x with 1, I get a times 1 plus 5. Solving, I get 1 plus 1 plus 5 is 7a, so 7a equals to 2, which implies a equals 2 over 7. Yes,
Yeah.
good. Next value of x.
Sub X equals 0.
Sub x equal to 0. Okay, can. Let's do that. So we'll get 2 times 0, which is 0, equals to a times 0 plus 5. Add on 0 plus c, which is c, times 0 minus 1, which is negative 1.
Yep.
Oh, but wait. A here, what do we know about a? 2 over 7. So we're going to replace it with 2 over 7. Okay, then what do we get? C equals to 2 over 7 times 5, just 10 over 7. Okay,
Okay.
then not done yet. Still need to solve for b. Sub x equals. Let's try something crazy. Let's try 10. Let's try 10. It just works. Doesn't matter what number it is. Or if you want, you can also pick 11 or anything you like. So let's just try that. So 2x becomes what? 2 times 10, which is
20.
20. Then a times 10 squared plus 10 plus 5. I'm just going to use a calculator.
115.
Sorry?
115.
115. Okay. Then you just put down 115 here. Plus bx plus c. We don't know what is b. We know what is 10. So 10b. Add on c, which is 10 over 7. Multiplied by x minus 1, which is 10 minus 1, 9. Oh? So wait. A is 2 over 7. I keep forgetting. Must remember. You already solve it, then you must just convert it into a number. Don't make your life so difficult with so many variables. Yeah, for now. Later you'll see a lot more variables. Okay, so now we try to solve for b. 20 minus 2 over 7 times 115 equals to 9 times 10, 90b plus 9 times 10, 90 over 7. Then you can make 90b the subject. So you get this guy, but you subtract 90 over 7. Yeah. Then just type in the calculator. 20 minus 2 over 7 times 115 minus 90 over 7. I get negative 180 over 7. So therefore b is equal to, just divide by 90. Negative 2 over 7. Can? I purposely pick x equal to 10. You should try not to do it. Pick smaller value that is not different, not chosen before. Okay?
Yep.
Okay, then therefore you can just replace the a I'm going to be lazy. I'll just cancel it straight away. A here will be 2 over 7. B here will be, what do we find now? Negative 2 over 7. C here will be 10 over 7. Okay, then that's your answer. Like this. Okay?
Yep.
Okay, then now for SOAP. Okay, now we're going to talk about the sum and difference of cubic equations. Sorry, I forgot to mention this. Sum and difference of cubes. So the pattern you need to remember is SOAP. Okay, whenever you got a cube plus b cube, you can factorize as a plus b times, can you recall? A square?
A square minus 2ab plus b square.
Wrong. There is no 2 in front. There is no 2 in front. 2 don't have.
Yeah, okay.
Plus b square. Take note that here is AP, always positive. Wait, let me write it down. SOAP, same, opposite, always positive. You see, it's always a plus sign. Here, maybe I use red color. It's the opposite. O for opposite. Opposite of what? Here is a plus, there is a opposite minus. Then here, it's the same. Because on the left side, you see plus, here also plus. Why do I need to use this same opposite always positive? Because a cube minus b cube, there's another identity. You just have to copy down the exact same letters. A, b, bracket, bracket, a square, a, b don't have 2, b square. Then can you tell me what are the plus minus signs I should put down? Here should be. Exactly. Same negative sign. Then opposite, so it's a plus sign. Then the last one is always a positive. Okay. Same, opposite, always positive. You can expand it out to check. Do you want me to expand for you and check?
I sort of did.
You did before? Okay. Then okay, I think I'll just do it. For the a cube plus b cube. So let's see. A plus b multiplied by a square minus ab plus b square. Let's expand this. So a times a square, you get a cube. A times minus ab, you get a minus a square b. A times b square, you get plus ab square. Sorry, square. And then after that, b times a square. Okay, b times a square. You get plus ba square. But you should realize that ba square and a square b are the same. Later, they will cancel off. Yep. Okay, and what else? B times negative ab, you get negative ab square. Again, they cancel off. And then plus b times b square, which is b cube. Yes, cancel. And at the end of the day, you're left with a cube plus b cube. Likewise for the other guy, a minus b times a square plus ab plus b square. I'll just do it a bit quicker. So over here, we have a times a cube, a times ab, a square b, a times b square, you get ab square, minus b times a square minus ba square, minus b times positive ab, you get negative ab square, negative b times b square, you get negative b cube. Again, they will cancel off. They'll cancel off. You're left with a cube minus b cube. Can? Okay, good. So that's a special identity. So how do you use it? I think I wrote down the solution for you already. Let me just go to the solution. I wrote down over here all these questions. So it's a bit like if you remember a square minus b square, you got a minus b times a plus b, right? A minus b times a plus b. It's a similar idea. Yeah, so all these 1000s here, you can rewrite as cube. Then you get a cube plus b cube. You can immediately factorize a plus b times a square minus ab plus b square. Likewise over here, however, you have to be careful when the coefficient here is not a 1. 125x cube and 216y square, y power 6. You have to rewrite it as 5x power 3, right? Because if you remember, a b power m is what? A power m times b power m. So 5x power 3 will become 5 power 3 times x power 3, which is 125x cube. Then you need to work backwards to get back to the 5x bracket cube. and so on and so forth. Similarly for the rest. Do you want me to go through?
I'm okay with anything.
Okay, I think I might be wasting our time if I go through. Maybe I'll just go through part C and maybe I'll just go through part D. Part D is a little bit challenging. So part D, if you take a look, right, here's one long-winded way of doing it. But the preferred way is the right-hand side one. I'll just go through the right-hand side one. So what you realize is 64 and 512 are common factors, has a common factor of 64. Okay, so you just factor out that 64. Then you get bracket x power 9 plus 8y cubed. So far, okay?
Yeah.
Yeah, but then you realize that 9 can rewrite as 3 times 3, right? So that means you can rewrite it as x cubed power 3. Oh, x cubed power 3. Likewise, with the y cube, you can rewrite it as a simple y to the power of 3. But since there's a 8 in front, you have to also take the cube root of 8, which happens to be a 2. That's how you get a 2 here. So 2y bracket cube, then you'll get your 2 cube y cube, which is just 8y cube. Is this part okay?
Yeah.
And good. Then that means that you got a cube plus b cube. You can just factorize it off. Just remember to keep on writing down the 64 in front. There's an extra factor of 64. You just have to keep on copying it down. But this part, you can just use the identity. This is a, this is b. Maybe I write down the formula again. A cube plus b cube equals a plus b, a square minus ab plus b square. Same, opposite, always positive. There is no coefficient 2 here. Don't have. It's just a minus ab. Okay, then you just use the formula. There's a, there's a b, there's a a square, there's a ab, there's a b square. Same, opposite. Oh, I just realized I made a mistake. Here. Opposite should be a minus, right?
Yeah.
Okay, sorry. Let me change that. I'll send you the updated file later. Okay, then I think I might have made the same mistake elsewhere. Same, opposite, always positive. So here should be a minus, minus. And then I factor out 16 over here. Oh, this is very long-winded. You probably should not do that during exam conditions. Okay, yeah. Then you can factorize it into this form. Okay, let me give you an extra question. Let me go back to this. This is a square minus b square is a minus b times a plus b. Extra question. This is not related to sum and difference of cube. But can you factorize x power 16 minus 1? Simplify it.
Okay.
What would it be?
Let
me give you a hint. 16 can be rewritten as 8 times 2.
Wait.
Yeah, that's good. Yes. But can we go further?
Yeah.
Oh my God. Plus, that's when you realize x power, whenever you got something square plus 1, you can't really factorize. So x power a plus 1, you have to leave it alone already. Leave this alone. Only the x power 8 minus 1 can. Minus 1 square. Which means you get. What will you get?
X4 plus x to the power 4 plus 1, x to the power 4 minus 1.
But wait a minute, x power 4 minus 1. Can you go further? Yeah, exactly. Very good. So I can replace it with x squared plus 1 times x squared minus 1. A, can I go further? You can go again. X plus 1 times x minus 1. A, can you go further? You can, but you have start to have fractional powers. But don't do that. Huh? We stop at a whole number power can already. So we just fill in the rest. Yeah, and that's it. Okay. This one is just intermediate working. Okay, that's a final answer. Okay. Yeah, extra question. Okay, that is sum and difference of cubes and partial fractions and long division. We also talked about factor theorem and remainder theorem already. Now I want to start a new topic on what do you call it? Binomial expansion. Is that okay? Or you want me to go through more questions? Can All right. Mike Tess, can you still hear me?
Yeah.
Okay, good. Can. Let's continue. So today we're gonna talk about binomial expansion. Okay, so this binomial expansion, who came up with it? Yeah, it was Newton.
Oh.
No. Binomial bi is what do you call it? Bicycle. It means two. It means two. It's basically asking you to expand a plus b to the power of n, where n is any integer 1, 2, 3, 4, 5, can be 0 as well. 0 and 1 are trivial. You don't really need to do anything. Who came up with this? It's a guy called Newton. You know Newton physics or the calculus stuff? All the forces, apple drop on his head. He came up with all this. Okay, so how does it work? There is a formula. It goes like this. And then you have this. And then you have this. Can you see a pattern? Can you see the pattern?
Uh,
Let me highlight it. Blue color. Can you see? 0, 1, 2, 3. Then what do you notice about the power? The other guy. Power n, n minus 1, n minus 2, n minus 3. It's a countdown, right? Can see or not?
okay.
This one is countdown. Let me just write it down first. What else do you notice about the sum of the powers? What's 0 plus n?
0 plus n.
Then what is 1 plus n minus 1?
N.
Yes, all of them is n. Good. So that is the pattern. 2 plus n minus 2 is also n. 3 plus n minus 2 is also n. You get the pattern already. So that's the key idea. The sum of their powers is always equal to n. This one I'll just write down count up. Okay, eventually when will it stop? You will have to count down until all the way till it becomes n choose n minus 1. I'll explain why it's choose later. Then here it will become n minus 1 b power 1. No more space. Let me write below. N choose n times a power n times b power 0. Okay, I think you know, right? Anything power 0 is equal to what?
Anything equal to 1.
Always equal to 1. How about 0 power anything? 0 power 1, 0 power 2, 0 power 3?
0.
0. Then what happens if any is equal to 0?
Assume equal to 1.
Yeah. It's what we call indeterminate form. Indeterminate form. Okay, basically this is not in A max syllables. It will also it is also not in the A level H2 max syllables. I think it is in further math. Okay, indeterminate form. And also definitely in university or in poly if you go in engineering course. When you study about something called limits. What you realize is that if I replace any here with 0, I get 0 power 0 equals to 1. If I replace the any here with 0, what do I get? 0 power 0 equals to 0. So that means that 0 power 0 sometimes equals to 1, sometimes equals to 0. Don't you find that weird?
Yeah.
Yeah, right? So for now, I'm just going to ignore this case. We will never encounter this. If we do, well, to be honest, I'm not sure what's the correct procedure to continue. I think we'll assume it's equal to 1. We'll assume this. Assume that equals to 1. Assume. Okay. Let's just list down a few more other identities you should know. 1 power anything is just 1, right? 1 power 1, 1 power 2, 1 power 3. And there's one more, anything to the power of 1 means anything itself. So for example, if it's 5, that's an invisible power 1. If it's x, that's an invisible power 1. If it's x squared plus 1 over y cubed bracket, that's an invisible power 1. Can you see the invisible power 1? Everything has an invisible power 1. Can? Hello, mic test, can you hear me?
Yeah.
Can? Okay, good. So in that case, this formula, do you know what it means? Do you know what is this notation? I don't know. You went to JC for a few months, right? Do you learn this?
No.
No, This one is a notation for n choose r. Do you know what is n choose r?
Something you can type in the calculator, but I don't know what it is.
Okay, very simple.
It's here.
It's C, correct. What it means is actually combination. Have you heard of permutation and combination?
No.
Permutation and combination is basically a topic that is in H2 Max, also in H1 Math, where it's called mathematical counting. So basically, let's just discuss what is NCR first. Before I go into the formula. So NCR in this case means a scenario like this. Let's say you have a wardrobe, and then you have many t-shirts. Yeah, my t-shirts are squares, okay? Square. 1, 2, 3, 4, 5. And then let's say there are different colors: red, orange, yellow, green, blue. But because I am bad at spelling, I'm just gonna write numbers. Index number 1, 2, 3, 4, 5. I got 5 different t-shirts. Right, this is a wardrobe. Then let's consider a bag. You have a bag like this. And then inside the bag, you can only put in, let's say, for example, 3 different items. You only have space for 3 different items. Then you don't care what order you pick the items. So there's like 5 different colors, right? Or 5 different flavors or whatever items. And you want to choose 3 of them. How many ways are there?
To 5 times 3.
From 5 items to choose 3 of them. No, it's not 5 times 3.
5
see,
times 4 times 3 times 2 times 1. No.
Not really. Think of it like this. Maybe my bag, I redraw it as 3 boxes. Your first space here. How
5
many?
times 4 times 3.
Very good. Exactly 5 times 4 times 3. Yes, that's the answer. Okay, so the answer is 5 times 4 times 3. But you notice I purposely phrase it in a very weird grammatical way. How many ways from 5 items to choose 3? 5 choose 3. What do you think the C here stands for?
Choose.
Yes, choose. Do you know how to type choose on your scientific calculator?
Yeah.
So you write down a 5, then you put a C, then you put a 3. This is actually exactly the same as 5 choose 3. Did you know that? Oh, the way we write it is different country got different ways. Singapore AMAX style is 5 on the upper left corner, put a C, then put a 3 at the right side, bottom right corner. Top left and bottom right. Big number is always at the top left. Does that make sense? 5 choose 3. Are you convinced? You get a 10, right?
Yeah.
Can so is this one so 5 choose 3 is just a shortcut for you to write out 5 times 4 times 3. Okay?
Okay.
Number of ways. So now how does it link to this binomial expansion, and what is this A, what is this B, and what is this N? Maybe I'll just start you off with a simpler example. Okay, I'll come back to the general formula later. So let's say you start off with x plus 1 to the power of 2. Of course, you know how to expand this, right? Just x plus 1 times x plus 1. And of course, you know your formula you memorized before, x squared plus 2x plus 1. Is that okay?
Yeah.
I want you to notice the pattern 1, 2, and 1. Okay, 1, 2, 1. Let's expand, increase it to what x plus 1 power 3. What would it be? It will just be x plus 1 squared times x plus 1, which means I can use my answer from before, 1x squared plus 2x plus 1. I multiply by x plus 1. Expand everything, I will get x cubed. I'll start with the first term and I distribute. So x cubed plus x squared. Then second term, 2x squared plus 2x. And then plus 1x plus 1. I purposely write it in this format so that my like terms are in the same column, so it's easier to read. I'll get x cubed plus 3x squared plus 3x plus 1. Pay attention to the coefficients. 1, 3, 3, 1. Okay? How about x plus 1 power 4? You see before Pascal's triangle. Do you know about Pascal's triangle?
No.
What you've just drawn is Pascal's triangle. Do you know how to construct the triangle?
No.
Can you but okay, I'll just write it down for you and you think about it before I review. I give you like 1 minute. 30 I'll give you 20 seconds before I review the answer.
Like plus what do you mean?
Exactly.
Okay.
That's it. Yes,
Oh,
correct.
okay.
Yeah, that's it. You just have to take the top two numbers, add them together, you get the bottom number. Like 1 plus 3 is 4. You must make sure you must start with the triangle of ones first. Triangle of ones. 1, then 1, 1. Then at the left end, you must always have ones. This one compulsory. Then after that, you go and do the left right sum together, give you the bottom number. So for example, 1 plus 1 add together gives you 2. 3 plus 1 gives you 4. 6 plus 4 gives you 10. So continue. 1 plus 4 gives you 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then a 1. And so on so forth. You can keep continuing. I just add on one more. Add on one more. 1, 6, 15, 20, 15, 6, 1. Okay. Now, let's label the rows. This one, maybe it's nicer if I draw horizontal lines like this. Then I duplicate them somehow. Okay, this is not a good idea. I'll just manually draw it. Here, here, and here. Okay, I'll call this n equals 0, n equals 1, n equals 2, 3, 4, 5. Okay, yeah, 6. Just finish up. Okay, these are what we call the n rows. Okay, the nth row. Then I hope you notice by now, the pink color highlight 1, 2, 1. Do you notice it's the same as this one? How about this one? 1, 3, 1, 1, 3, 3, 1. It's the same as this one. Do you think that okay, do you know what's the formula to get any random number here? Let's say for example 10. How do you get this 10 here? Instead of drawing out the triangle all the way.
How do you get the 10 there instead of drawing random triangles all the way?
Instead of drawing this, not random triangle, it's a Pascal's triangle. Like for example 10. How do you get this 10?
How do you get this 10?
Can you see a pattern? Can you see how it's related to the choose function? Make a guess. Or think about 20. Maybe you think of a formula for 20.
Oh,
How? Let's say 20. How do you get 20? What choose what?
6 choose. 6 choose. I mean,
Just trial and error. Just spam on your calculator.
6 choose 5.
5 ah? Huh? Wait. Hold up. 6 choose 5. You type in a calculator. I think I get a 6. Check. 6 choose 0, 6 choose 1, 6 choose 2. What is it? Do you have your scientific calculator with you?
Yeah.
Okay. So what is it?
Uh, what the? It's not.
Hmm?
What is it?
So have you tried it already?
Yeah, I'll try it now.
Do you know what I'm asking you to do? I'm asking you to go and play around with the choose function. Pick choose can you key in these numbers? 6 choose 0, what do you get?
1.
Okay, then what 6 choose 1?
6,
Then what 6 choose 2?
15, 20.
You see a pattern?
Oh,
Then
yeah,
continue.
okay.
Try until you must really type in the calculator and see for yourself. 6 choose 3.
6
choose 4?
choose 4, 15. 6 choose
Yeah.
5, 6. 6 choose
Good.
6, 1.
Exactly. Let's try a number. 6 choose 7. Can or not? What do you get?
6 choose 7. Math error.
How
Not
about 6? Because it exceeded 6, right?
Yeah.
So what also you must play around with the calculator and you realize that 6 choose 7 math error. Why? The reason is here. Bigger than 6. Okay. And then let's say you choose you do 6 choose -1. Does it work?
6 choose
6 choose
negative
-1.
1.
6 choose -1. Does that work? On your calculator, it will be
Math error.
math error as well. So what do you learn? Here, why is it an error? It's because there's a negative here. You cannot have negative, right? Math error. Let's say any other examples. Let's say decimal. 6 choose 0.5. Can 6 choose 0.5?
6 choose 0.5. Math error.
Math error as well. Why? It means that, okay, there's not much why to it. It's just a rule. Here, no decimals. In fact, over here also, the same rule applies on no decimals. Okay, so from this experiment, we conclude some properties about the choose function. Let me just go back to, I should leave a space here. Hold on a second. Yeah, okay, some properties of the n choose r function. Properties. Number 1, you realize that n must be bigger than r, right? Example, 6 choose 7 doesn't work because your r is now bigger than n. Number 2, n and r, okay, I didn't give you some experiment for the n, you can try on your own. N and r must both be positive whole numbers, positive integers, whole numbers, or 0. Okay, actually, n cannot be 0. Sorry. N choose 0. Okay. Actually, can. Sorry. N will usually be a big positive. Then this R will be a small positive. Okay. That's some of the patterns. Also, Yeah, because they are integers, that means they are not decimals. Positive means not negative. Just take note. And you also realize that they are the more important point, the binomial coefficients,
Okay.
which is also the same as the terms in the Pascal triangle. Okay. So now let's do, since you I think you can see a pattern here, which is that you can actually just quote one of the rows of the Pascal triangle in order to get the binomial expansion. Binomial expansion, maybe I didn't explain it clear enough. It means bi means two, right? So here you see two terms being added together. Two terms are one term here, second term there, bracket to a certain power. So now can you use this table, this Pascal triangle to make a good guess? What do you think is x plus 1 to the power of 4 without manually expanding? What do you think it is? Can you see a pattern? 2, 1, then here there's an invisible x power 0.
Yeah.
Here is 3, 2, 1, 0. Then just count down all the way, x squared, then x and constant. Then what's the coefficients? Exactly, that's it. You understand already. Okay, yes, that's correct. Okay, I'll write it down for you. 14641. 14641. Okay, so just to convince you, I'm gonna manually expand this. Let's see. Manual style. X plus 1 power 4 is x plus 1 square times x plus 1 square. Never mind. I think I'll just x plus 1 cube times x plus 1. But I already have x plus 1 cube, which is x cube plus 3x squared plus 3x plus 1 multiplied by x plus 1. Let's expand this. Okay, I'll do it a bit quickly. X cube. Maybe I'll just do this guy times x plus 1. So x cube plus, x power 4 plus x cube. Then 3x squared times x, I get 3x cube. 3x squared times 1, I get 3x squared. 3x times x, I get 3x squared. Then 3x times 1, I get plus 3x. 1 times x, I get x. 1 times 1, I get a 1. All together, I get x power 4 plus 4x cubed plus 6x squared plus 4x plus 1. Pattern 1, 4, 6, 4, 1. Which is the same as what you wrote down. Can? Convinced?
Mhm.
You can try this for all the other experiments. And also, by the way, here I made your life easy by starting off with a 1 over here. But it doesn't have to be a 1. It could have been any other number. And the pattern is you need to have a sum of the powers to be equal to n. If you remember the general formula over here. There's a b, right? Here, I purposely choose my b to be a 1 to make your life easier. So you can see the pattern. But when you have a b that is non-zero, sorry, that is not 1, it becomes a lot more difficult. Because here, what happens is that when a b is 1 power n, 1 power n minus 1, 1 power n minus 2. And if you remember, 1 power anything is always 1. So I was making your life easy. It's gonna be even more difficult in actual.
Oh my god.
That's why you need this formula. You don't want to manually expand. You see, it's taking quite some time to expand this. So you want to have a general formula. Which is what I started off with. So let's see. Let's do. Sorry, I haven't talked about the relationship. Sorry. Just now I told you about the story about a wardrobe and a bag, and then you choose items 5, 4, 3. How is it related? Why are the coefficients related to the choosing function? How is it related to choosing shirts from a wardrobe? Right, so magical. Why? Why does it happen to be the same?
What do you mean?
Like here you see 14641, right? it's 6 choose 0. Actually, no, this one is 6 choose 0. 6 choose 0. That guy is 6 choose 1. It starts from 0. Then 6 choose 2, 6 choose 3, and then last one is 6 choose. Did I miss out something? Oh, sorry. This one not 6, this is 4. Sorry. Because power 4, power 4. Apologies. Yeah. Forgot. I'm at power 4. 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. Okay. So, what was I saying? The question, why is it related to the choose function? Choose function is it starts off with the question of having shirts in your wardrobe, and then you choose a few things to put in your bag. How is it related to algebra? Like why is it such a coincidence? 1 plus 3 suddenly give me 4. 3 plus 3 give me 6. What's going on? So the reason here, how I can explain this is like this. Every time you expand a binomial power, you should realize by now that you will always get something power times x power 4 plus something times x power 3 plus something times x square plus something times x plus a constant. Let's just assume that it's 1. Are we okay with this? Are you okay with accepting this?
Yes.
So x plus 1 power 4, let's say we begin before we know about the Pascal triangle and the manual expansion, we reinterpret it like this. We know that it will expand, after expanding, it must look like this format. Then our goal is to find out what are these boxes. We already know the answer, 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. But let's try to figure out why that's the case. So over here on the left-hand side, x plus 1 power 4, I can actually reinterpret it like this. X plus 1 times x plus 1 times x plus 1 times x plus 1. Correct or not?
Mhm.
It's the same. So let's think about it. How do you get x power 4? Oh, actually, sorry. Let's start from the left-hand side. How do we expand this? How do you expand binomial times binomial times binomial? If I start off with something simpler like x plus 1 times x plus 1, how do I expand?
X plus 1 square.
Yes, but you do distribution, right? Like this.
Yeah, okay.
Right? Okay, correct. So what you realize is that whenever you try to expand this, you always start off with the first factor and a second factor. You start off at the first factor, and then you pick one guy. Who do you pick? You either pick x or you pick 1. So let's say we pick x. Then after that, you go on to your second factor. You either pick x or you pick 1. If you happen to pick x, then you get your x squared term. If you happen to pick your, you see my arrow moving over. If I start off with the first factor, I pick x. Then the second factor, I pick 1. I'll get x times 1, which is x. Then after that, I move on. First factor, I pick the second one. Then I pick the first factor. 1 times x. Then I get an x. Likewise, sorry.
Yeah.
Okay, that was a funny sound. First factor, I pick the second term. Then second factor, I pick the second term. I'll get 1 times 1 is 1. Oh, that's how you expand. But you can reinterpret it like this. How about thinking about it like this? I want something x squared plus something x plus something. How can I obtain x squared terms? Definitely it will be x times x, right?
Yeah.
So that means how many ways are there to pick? I need okay, sorry. X squared means x times x, which means I need 2 copies of x. How can I obtain 2 copies of x? 1 here, 1 here. So how many ways are there to do it?
1.
Only one way, or rather, you can think of it like this. You have 2 copies of x, and you want to choose 2 of them. Correct or not? 1 copy of x here, another copy of x here. You want to choose 2 of them.
Okay.
Then over here, there's like you want to get 1x. How do you get 1x? You have a single x over here. You want to pick it, and then you have to multiply by the constant, so you get x power 1. Or you could go the other way around. The other x there, and you multiply by 1. So there are 2 options, but you only want to pick 1 single x. So 2 choose 1. And then the last one will be 2 choose 0. Does that make sense?
Okay.
Sort of. Okay, so we're going to do the same thing here, but now we jump straight away to power 4. Okay, let's think about it. How do we get power 4? You have 4 possible x candidates. You need to select all 4 of them. So it will be 4, choose 4. Then now you got x power 3. How do you get x power 3? Let me show you all the possibilities. It will be, I pick x here, x here, x here, and then I pick a constant. Or I pick x here, I don't pick an x here. Okay, maybe I put a cross. Cross means it's I pick a constant. Or it could be I pick a constant here and then I pick an x. Or the other way would be I pick an x here, I pick a constant here, I pick an x here, I pick an x here. Or it could be the last one. I pick a constant here, I pick an x, I pick an x, I pick an x. Make sense? 4 ways. 4 possibilities, right? How do you get this number 4? 4 ways. 4 ways. How do you get this number 4? Think about it like this. You have 4 options, and then you only want to choose one particular constant. Among these 4 factors, you want to choose one constant and 3 x's.
Okay.
How many ways are there to do that? It's either 4 choose 1 or 4 choose 3.
Mm-hmm.
Do you realize that they are equal? Did you realize that they are equal? Type in a calculator. It's the same. You either pick. It's because once you pick the or you force yourself to only pick a single constant, then all the other factors you must still pick one of them. So there's only the other options you must pick x. Or you can think of it as among the first 3 factors or among the 4 factors, 3 of them I want to pick an x, which leaves the last option, which means that you will be forced to pick a constant in the last factor. So it's 4 choose 3. The other way would be 4 choose 1. You force yourself to pick only one constant, then the other 3 just tags along. So this one will be 4 choose 1. Okay, so maybe it will be nicer if I think about it in terms of how to get x power 4. Think of it as I don't pick a 1. I don't pick x. I don't pick x, I pick a constant. I don't pick x, I pick a constant. I don't pick x, I pick a constant. Which means I chose none of the x's. Which means that this should be a 0. Does that make sense?
Okay.
I chose 0 x's. Then likewise, you can follow the same logic. You'll be 4 choose 1, you pick 1 x only. You pick one constant only, sorry. And then the last one will then the second one will be 4 choose 2 because you are picking 2 constants so that you'll get 2x. Right? I pick constant, and then x. Okay.
Okay.
Yeah. Oh, by the way, these 4 ways what I mean when I say pick, it means that I pick x. The first option means that I take x times x times x times 1. So this one will give me x cubed. Then the next one, I take x times 1 times x. This one will also give me x cubed. Then the next one will be, I pick x here, I pick 1 here, I don't pick x, then I pick x and I pick x. So again, another x cubed. And then the other possibility will be, I pick a 1 here, then I pick x, which gives me an x cubed. So because there's 1x cubed, 1x cubed, 1x cubed, 1x cubed, 4 of them, add them together, you get 4x cubed. Or 4x cubed, which is 4 choose 1. Okay? Yeah, then likewise for all the others, it will be 4 choose 2, and then 4 choose 3. You can think about it. 4 choose 3 means what?
4 choose 3 means is it, what do you mean? What do you mean by what it means?
Yeah, why is it 4 choose 3?
Because there's like you need 3 constant and then 1 x. Then there's like 4 ways, and then there's like
All right, yeah, that's 4
I don't
ways.
know how to say.
Yeah, correct already. Yes, you have one single x, which means that maybe I should just write it in the more general form, then it will be clearer. So what I mean is there's those invisible ones. You're multiplying by 1 to the power of 0. you're multiplying by the x cube is being multiplied by 1 power 1. The x square is being multiplied by 1 power 2. And the x is being multiplied by 1 power 3. Yeah, so exactly what you said. You want a single x, it means that you have to pick 3 copies of 1.
Okay.
And there are 4 choose 3 ways to do that. Yes. And the one here, the last one is actually, if you want the most general form, 1 is actually the same as 4 choose 4 multiplied by x power 0 multiplied. Oh, by the way, when I put a dot here, it means multiply. You know that, right? Means 5x. Okay. Then x power 0, then 1 power 4. Okay? This is just one. This is a very long-winded way of saying one. Correct, right?
Yeah.
Correct, right? Not confused, huh? Oh,
Yeah.
sorry. Power 0 is 1. This one is 1. 4 choose 1. 4 choose 4 also 1. 1 times 1 times 1 is just 1. Okay. So now now that you're convinced of the formula over. Oh, by the way, I didn't explain. Sorry. The notation. N choose R is exactly the same as N on top and R below, where you put open bracket, close bracket. This is not a 2x1 matrix. This is just binomial coefficient or the N choose R notation. Okay, they mean the same thing.
Okay.
Can? Yeah, it's just that's why at the beginning I had this N choose 0, N choose 1, N choose 2, N choose 3 pattern. Okay, let's try some examples and see how we can use that formula. Maybe I'll just copy down the formula. Oh, wait, no, I'll just rewrite it. Let's do some examples. So the formula goes like this: a plus b power n equals to n choose 0 times a power 0 times b power n. N choose 1, a power 1, b power n minus 1. Blah, 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 until n choose n minus 1, a power n minus 1, b power 1, plus n choose n, a power n times b power 0. Let's see. So let's say we have x plus 2 to the power of 4. How to expand? It will simply be 4 choose
0.
Or you could have written
Yeah.
4 choose 0 like this as well. Then times x, right? The a is x to the power of 0 times 2 to the power of 4 plus 4 choose 1 times x power 1 times 2 power 3 plus 4 choose 2 times x power 2 times 2 to the power of 2. And just continue all the way.
Okay.
Yeah, correct. You have to be focused. Like it's quite often students will just 4, 3, 2, then suddenly go back to 3. You count down halfway, then suddenly count up again. 4, 3, 2, then suddenly you get confused. You tired already. Then you suddenly count up again. When it should be a 1. Okay. Very common. Just warning. Then you get a power 4 and then 2 power 0. Which is really just a long-winded way of saying 2 power 4. No, x power 4, sorry. Oh, okay, let's just simplify this. Of course, if you don't want to manually key in the calculator, you can go and draw your triangle. Draw your triangle. So just quickly construct it. 1, 1, 1, and then 1 at the left, 1 at the right. Sum of the previous two numbers, 1 plus 1 gives you 2. 1 on the left, 1 on the right. Sum of the previous two numbers, 1 plus 2. Sorry, I zoom in. Gives you a 3. 2 plus 1 gives you a 3. Likewise, 1 on the left, 1 on the right. 1 plus 3 gives you a 4. 3 plus 3 is 6. 3 plus 1 is a 4. And I can stop already because the moment I see 4, I know this is the n equals 4 row. N equals 4 row. So I can use the coefficient 1, 4, 6, 4, 1. I know for sure that maybe I'll just write down the alternative notation first. I know for sure that each of these fellas is just 1, 4, 6, 4, 1. Okay, using the calculator. Is that clear?
Yeah.
Can. Okay, then what you get? You'll get 2 power 4. Okay, you know what? I'm a bit lazy. I'm just gonna copy and paste this. Save some time. copy and paste this, and then I'll just erase away the non-necessary information. Okay, so this power 0 disappears. Okay, I don't really have any non-necessary information, but yeah, something like this, huh? Can bring it down. Okay, like this. It simplifies down to this. Is that clear?
Yeah.
Then of course, here is a number, there is a number, you can multiply. 2 cube is 8, 4 times 8, you can do 32, and so on and so forth. Let's just, I'll just do it quietly while you watch. I think you can understand what's going on.
Hmm.
Six times 2 squared is 24. And then 4 times 2 is 8. 1 times anything power 0 is 1, right? 2 power 0 becomes 1. 1 times 1 is just 1 times x power 4. Answer. Is that okay?
Yeah.
If you want, you can manually go and expand this. Manually go and expand. It will work. Get the same answer. But yeah, don't. That's the point of this this topic. It's too long-winded. Don't do it. Use the formula.
Yes.
It will work. Okay, let's just go to the application question. Do you see the file I sent you?
Yeah.
Yeah, we're gonna practice questions from that paper. I think one example is good enough. Let's just start a new page. Please refer to the binomial all questions worksheet. I'm not sure. I don't have time to go through. I'm just going to go through some of the questions there. So let's begin. Okay. Okay. Maybe I should share screen. Hold on a second. Share this screen. I think it's the correct one. Am I at the right page? Yeah, I think so. Okay, this one. Can you see? Some tips on binomial theorem. These are not questions. Okay, so some of the problem solving tips that you need to solve questions involving binomial expansion are the following. Number 1, use the formula of NCR, or rather N choose R. Yeah, just I didn't mention the formula. I'll talk more about the formula later. It's just 5 times 4 times 3. But you must generalize it. Okay, and then number 2, use binomial expansions to estimate the value of a number. So make sure you have the approximation sign somewhere in your working. I will show you some example questions later. Number 3, find the unknown n in the expansion of bracket 1 plus ax raised to the power of n, where n is an unknown, r and the terms in the binomial are given. Number 4, you want to find the r plus 1th term in the binomial expansion of a plus b to the power of n. N, R, and binomial terms are all given. Number 5, find the term independent of x. What does independent of x mean? It means constant. Okay, x power 0. In a binomial expansion, also known as the constant. I wrote that. Then number 6, find the r plus 1 term in the binomial expansion of a plus b to the power of n. Not enough, you still multiply by a c plus d. Oh, sorry, maybe it should be a cx plus d. They like to make your life difficult. So for example, something like this. Find x, for example, you'll be asked questions like this in AMAX. Find the coefficient of x to the power of 11 in the expansion of bracket x squared plus 2 over x squared close bracket to the power of 9. Then you multiply by 2x plus 3 over 4x. So you can imagine power 9. You do not manually expand it. You can, but you do not do it. You use the formula. You need to learn the formula. Yeah. Then number 7, you expand the first few terms of a trinomial expansion. What's trinomial? Means inside the bracket, you see how many terms? 1 plus x plus 2x squared, for example. 3 terms. Tricycle means 3. And then the whole thing is raised to the power of 4. You are expected to solve this. Then the question will be asking something like, find in ascending powers of x the first 4 terms of the expansion. Bracket 1 plus x plus 2x squared, close bracket raised to the power of 4. The answer will be 1 plus 4x plus 14x squared plus 28x cubed. You're expected to be able to expand this. Yeah. Yeah, it's in AMAX. Yes. Then number 8, finding unknowns inside of an expression. N is given, R is given. I'll go through all the examples of questions in all these points. You'll be clearer after the few lessons. Then point number 9. Given the ratio of the coefficients of two specific terms in an expansion, you want to solve for unknown p. So for example, in the TYS 10-year series 2017 on paper 2, question 3 part 2, you got px cubed plus 1 over x, whole thing raised to the power of 9. They tell you the coefficient of the x to the power of 11 term is double that of the x power 7 term. Then you want to find the value of the unknown p. Do you think you can do it now?
No.
Okay, we'll figure out how to do it. I cannot finish it by today. So let's just begin. I hope you have the file open with you because I need to change my iPad now.
Okay.
Yeah, okay. How do I assign homework? Need to prepare more questions. Let's see. So this question number 1, point the binomial theorem, binomial expansion. Use the formula of NCR and use binomial expansion to estimate the value of a number. Make sure you got the approximation sign. Sorry, I forgot to mention. Just now I gave the example of the wardrobe. Maybe I go back to the wardrobe. The wardrobe here. You got 5 choose 3. You realize it's 5 times 4 times 3. But in general, what if I just I need more space. Let me rearrange my notes a little bit. Yeah, something like that. Okay, so what we realize is that, like in this case, 5 choose 3 is just 5 times 4 times 3. But let's say I make bigger numbers. What would 7 choose 2 be? It means you have
7
times. It means you have a wardrobe with 7 different types of clothes, and then you have a bag that can only contain 2 clothes. How many ways? First space, you got 7 options. After you pick 1 shirt, then you're only left with 6 options. 7 minus 1. Then you have 6 options. So what's the total number? 7 times 6. That's all. Make sense?
Yeah.
Then let's say I pick another number. Let's say 100 choose 3. What would it be equal to? Means you have a wardrobe with 100 different types of clothes. And you have 2.
100 times 99 times 97.
Huh?
Wait, what?
You mean 98?
Yeah, I mean 98.
So you stop after you see 3 numbers because you see 3 It means your bag only got 3 spaces. And you don't care about the order of the let's say you're a messy person, and then you don't care about the order that you stuff the t-shirt inside your bag. Okay, so let's generalize this. If I now wanted, let's say n choose r, can you think of a formula for me?
equals
n
to
times n minus 1 times, when do I stop? Right, you notice it's countdown, right? Countdown.
yeah.
So when do you stop?
Until r is equal to the negative thingy.
Really? Okay, let's see. In this
Wait,
case,
no, I changed my mind. R.
How do you link n and r? Something involving n r. How do you link 98 to 103? 103, 98. 6 here? Oh, are you writing something? Sorry. Yes.
No, I'm just, I don't know.
Think about it. How? 7, 2, and 6. How do you link them together? I need more space here. And the last digit here, it's always focusing on the last digit, right? That's when we know we had to stop the multiplication. So 5, 3, and the last digit is 3. Can you see a pattern? Yes, correct, exactly. So if I expand it, 5, oh, sorry. Correct. The digit just before 3 is 3 minus 1, 2. But if I just expand it, I'll get 5 minus 3 plus 1, right? Likewise for this 6 here. How do I get the 6 here? It's really just well, no space. Where can I write this? Let me just write it in blue color so you can see the difference. Likewise over here for the 6, how do I get this 6? You can think of it as 7. You minus away the small number 2, but you subtract away 1, which is nothing but 7 minus, if I just expand it, wait, need more space. 7 minus 2 plus 1. Notice the plus 1 at the end. How about 98? It's 100 minus away 3 minus 1, right? Which is just 100 minus 3 plus 1. Okay, so it's always big number minus small number plus 1. Big number minus small number plus 1. Big number minus small number plus 1. Make sense? Big is the top, small is the bottom. So in general, the formula must end at, this is taking up too much space. I'm just gonna get rid of that. At the end of the day, you just basically have to count down all the way until you reach n minus r plus 1. Okay, that's the formula. Last term. Sorry, not last term, it's last factor. Okay,
Okay.
this is the general formula. But can we go even better? Go even more? Can we generalize it even further? Yes, we can. Let's see how we can generalize it further. I need even more space. Hold on a second. Do you know something called the factorial button? The exclamation mark?
Oh, it's like n equals to like n times n minus 1 times n. Is it
Correct.
something?
When do you stop? Yes, correct. So for example, let's just list down some examples. Oops, sorry. Exactly. It's smarter if you wrote it in the other direction. So let me just draw it for you. Sorry. 0 factorial is 1 by definition. 1 factorial is also 1. 2 factorial is 1 times 2. 3 factorial is 1 times 2 times 3. But maybe most people don't think of it as counting from the bottom to the top. So it's nicer if I wrote it the other way around, which is like the other way around, which means I write it like this. 1 factorial will be 1. 2 factorial will be 2 times 1. 3 factorial will be 3 times 2 times 1. Oh, countdown. It's called the countdown function. I like to call it the countdown function. It's just called a factorial. It's not. You don't see 3 exclamation mark, then you say 3, 2, 1. No, you don't. It's not exclamation mark. It's a factorial. Okay. 4 factorial is 4 times 3 times 2 times 1, so on and so forth. Right?
Okay.
Can. So how can we convert this funny notation, funny n choose r formula into something in terms of factorial? The formula is really simple. It's just n factorial over r factorial times n minus r factorial. Can you see why?
Yeah.
Can see, yeah. Okay, let's just do with
no.
cannot. Okay. Let's just do with some examples. So 5 choose 3. Just now we got 5 times 4 times 3. Do you agree with me that it's 5 times 4 times 3? Then I multiply by 2 times 1. Then I divide by 2 times 1.
Sure.
But wait, what's the numerator now?
Numerator is now 5. Yeah.
Factorial. Then the bottom, the denominator?
2 factorial.
Did I do something wrongly? Let me see. So hold on a second. Let me think a bit. Top and bottom by r factorial. Hold on. Let me just Google this. I might have remembered it wrongly. And choose r formula. Yeah, correct. Okay. I'm on the right track. Okay, so what we get is 5 factorial over 2 factorial. But is there something wrong with this formula? Yes, there is. Yes, there is. I think I gave you wrong information. 5 choose 3. Let's just double check with a calculator what's 5 choose 3. Let's double check. Sorry. I realized I made a huge mistake here. I forgot to divide by r factorial. Let's just double confirm. The number of ways for us to pick 5 items from among 5 items to choose 3 items, right? Where we don't care about the order. Is it actually 5 times 4 times 3?
No.
No. It's fewer, right? Because we don't care about the order. It's 10. How do you get 10? You actually need to divide by 3 factorial. Sorry, I forgot to mention this. Why divide by 3 factorial? Because each unique way of picking the items, let's say you pick a 1, a 4, or 5, you can arrange it in 3 factorial ways. It can be 145, 154, 415, 451, or 514, 541. If you represent this, which this is 3 times 2 times 1, this is actually 6 ways. These 6 ways can actually be rewritten in the following format. If I draw a tree, I think you draw it before in Emacs. Also, a tree looks something like this. It's like option number 1, option number 2, and option number 3. First, second, and third. You can either pick a 1, a 4, or a 5. But then within each option, you can also pick 1, 4, or 5. Right? So it splits up into 3 sub branches. And then within each branch, you can further split up into 3 branches. 1, 1, 4, or 5. 1, 4, or 5. 1, 4, 5. 1, 4, 5. 1, 4, 5. Oh, so basically the total number of ways will be sorry. No. Oh my goodness. Can I rewind? I'm sorry, I explained wrongly. Can I rewind 5 minutes?
Okay.
Or maybe 2 minutes. I can't remember. Okay. Yeah, let's start again. Okay, so what you have now is you have decided on picking shirt number 1, number 4, and number 5. You want to put inside your bag. Whenever you multiply 5 times 4 times 3, you are considering also all of the possible ways that you can arrange this unique combination of 1, 4, 5 in the following way, right? Of course, you can interpret it like this. After you pick 1, you're only left with 2 more options, which is 4 or 5. If you pick 4, you're left with 2 options, 1 or 5. If you pick 5, you're left with 2 options, 1 or 4. And then within each one, after you pick 1 and 4, you're only left with 5. After you pick 1 and 5, you're only left with 4. Likewise for all the others. 4 and 1 pick already, you're left with 5. 1, 4, 5 pick already, you're left with 1. 5, 1 pick already, you're left with 4. 5, 4 pick already, you're only left with 1. So that's why you'll notice that there are 3 branches, and then within each branch you have 2 sub branches, so times 2. And then within each sub branch you have 1 option only. So 3 times 2 times 1. That's the number of ways to arrange it, 6, which is really just 3 factorial. But we don't want to count all the possible ways that we can arrange the items inside our bag. We are a very messy person. We just throw inside our bag. We don't care about the order. So that's why we just divide by 3 factorial. Does that make sense?
Yeah.
Can I divide to make to only consider the unique combinations? This answer is 10, which happens to be 5 choose 3. You need the divide by 3 factorial. In general, it will be let me just go back to my formula. So sorry, I didn't mention this. I need to divide by 3 factorial. This one is divide by 2 factorial. This guy is divide by 3 factorial. Where the 3 here, 2 here, 3 here is referring to the bottom number, the R. Can see?
Yeah.
Yeah. You pick the number of t-shirts. This is like the bag contains 3 t-shirts, and then you divide by 3 factorial ways. You pick 2 t-shirts inside your bag. Then you have 2 ways to arrange it, 2 factorial ways. You pick 3 t-shirts in your way, there are 6 factorial, 6. Sorry, 3 factorial, which is 6. number of ways to arrange it, but you don't want all of the arrangements, so you divide. So in general, this formula, sorry, it's not equal. You have to also divide by r factorial. Okay, sorry about that. I forgot to mention. You must have the r factorial.
Okay.
Okay, then let's see the pattern. How do you link it from here to there? In terms of the actual examples, 5 choose 3 would be 5 times 4 times 3 over 3 factorial, but I can multiply, I need the 3 factorial, multiply top and bottom by 2 times 1, which means that the numerator becomes 5 factorial. The denominator here becomes 3 factorial times 2 factorial. I need an extra 3 factorial here. Okay, let's try another example. So let's say I pick 98 choose 4. What would it be? 98 times 97 times 96 times 95. Four of them. You'll notice that 95 is just 98 minus 4 plus 1. Right? N minus r plus 1.
Yeah.
And then you divide by the number of ways that you can arrange them. Divide by 4 factorial. But you can multiply top and bottom by, what do you call it? This time it's a bit ridiculous. You have to multiply by 94, then 93, then 92, all the way until 321. So you can do the same at the as the denominator, at the denominator, right? Multiply top and bottom so that the fraction stays equal. Do you agree?
Yeah.
But what happens to the numerator now? You start from 98, you count down all the way to 1. So it's actually 98 factorial over 4 factorial times 94 factorial. So in general, I think you can see a pattern. It's just n factorial over r factorial times n minus r factorial. Right? Can see a lot. 94 is 98 minus 4.
Yeah.
This because after n minus r plus 1, if you want to do it in general, it will be n times n minus 1. Okay, I'm just gonna drop the multiply sign. N bracket n minus 1, then n minus 2, dot dot dot, until you eventually get to n minus r plus 1. What's below n minus r plus 1? N minus r. Right?
Yeah.
Minus 1. Minus 1. N minus r plus 1 minus 1. Then you just keep on deducting by 1, deducting by 1, so on and so forth until you eventually reach to 3, 2, 1. Let me just highlight it in pink color. That's what the new thing that I introduced. If I introduce on the top, I also need to introduce on the bottom so that I can make sure the fraction stays equal. I multiply all these pink color factors at the top and the bottom. At the end of the day, the numerator is just counting down from n all the way to 1. That's why it's n factorial. Whereas the denominator r factorial remains, but the bottom part here is starting from n minus r, then you count down all the way to 1. That's why it's n minus r factorial. This part is the same as this part. Is that okay?
Yeah.
Okay, good. So this is the general formula. Sorry, I forgot to mention this. Yeah, I should mention this before I go into more the examples. Yeah, so let's just do a quick example. Let's using this formula. Let's say we got 9 choose 5. What would this be equal to? Can you tell me?
9 factorial. Then the bottom would be 5 factorial, and then 4 factorial.
9 minus 5 is 4. Okay. Yeah, then you can just key in the calculator. Okay. Oh, by the way, if you try to key this fella in the calculator, it might go very slowly, because a factorial function is extremely slow. Oh, you might need to put a right. You need to put our times over here. Sorry. On the on the calculator, you need to put our times over here. Okay. Times. Math notation, you don't need the times, but on a calculator, you need.
Okay.
Yeah. Okay. I think 98 factorial. I'm not even sure if the calculator can handle it. Yeah, you'll get a math error.
Yeah.
So sometimes factorial function is very scary. you better not use it all the time. It will be better if you use the original formula. Just counting, picking clothes from the wardrobe and put inside a bag. It's just that simple idea. And then you divide by r factorial because you don't want to arrange them. You don't care about the arrangement that you put the shirt inside your bag. Okay, this is this idea. Okay, Ken. So that is the formula. We will now begin the practice questions. Let's go. So question 1, let's take a look at the PDF file. You have 1 plus x to the power of 8, and you want to expand up to the third term in ascending powers of x. Hence, estimate the value of 1.001 raised to the power of 8. Okay, so how do we do that?
What even?
What even? Yes, you want to estimate 1.00 without using a calculator. Equals to what? This was invented in a time before calculators exist. So how do you expand this? You just have to use the formula. If you remember, let me just copy down. Let me just copy down this example to jog your memory, and then I bring it down to the bottom so you can have a reference how to expand this. Okay. So it will simply be 1 power 8. And sorry, maybe I'll just be more formulaic here. 8 choose 0 times 1 power 8 times x power 0. Oh, by the way, did I mention I can swap the terms around? Like you see, here is power 0 and there is power 4. Huh? I can actually swap it around. So power 4 on the x and power 0 on the 2. It's just going in the opposite direction. Do you notice that they are mirror images?
Okay.
You see, 1 x power 4 times 2 power 0, 1 x power 0, 2 power 4. They are mirror images. So that's why I pick a power 8 for the 1 and then power 0 because I want ascending powers of x. Okay, here is 0 because I want ascending powers of x. Later on, I'll increase it to power 1, then power 2, then power 3. So next one will be 8 choose 1 times 1 power 7 times x power 1. Can you tell me what's the next term? 8 choose
8 choose 2, 1 to the power of 6, x to the power of 2.
Okay, what did the question ask us for? Up to the third term in ascending powers of x. So do we need any more?
No.
3 terms already, then plus dot. Okay, always plus dot because we haven't finished expanding. By the way, do you know how many terms there will be if you expand?
There will be, is it 8 terms?
Close. It's actually 9 terms. Think about it.
Because
You
constant.
do quadratic. Yes, there's still a constant. Something x squared plus something x and still a constant. 1, 2, 3. It's always plus 1. Power 8, then you have plus 1, which is 9 number of terms. Okay, but you don't need to know that. Doesn't matter. The question asks for first 3 terms, we focus on first 3 terms. Simplifying, we get 8 choose 0 is just 1. 1 times 1 power 8 is just 1. Then x power 0 is still a 1. So we just get a 1. Plus 8 choose 1 is a 8. Times 1 power 7 is a 1. Then times 8x. 8 choose 2 is actually 8 times 7 over 2 factorial. Correct? Right? You have 8 shirts in your wardrobe. You want to pick 2 of them in your bag. So first space in your bag, you have 8 options. Second space in your bag, you have 7 options left after you pick 1. But you don't care about the arrangement because you are messy, so you divide by 2 factorial. Then times 1 power 6 is just 1. Then x squared plus dot. Simplify a bit more. We get 1 plus 8x plus 8 times 7, 56 over 2, you get 28x squared. Then what they ask you to find? Hence, estimate the value of 1.001. What is 1.001 power 8 extra 0? Power 8. Do you realize that it is actually just the same as 1 plus 0.001 power 8?
Sure.
Right? So that means my x is equal to what?
Your x is equal to
What's a good value of x that I can replace with?
What?
Is this guy, right? Can you see?
I mean, yeah, okay.
0.001. Okay. So we can sub just like partial fractions are very similar to partial fractions. Sub x equal to 0.001. But if we substitute x equals 0.001 on the left, we also need to do the same on the right. So we also sub x equals to 0.001. So what do we get? We actually get 1 plus 8 times 0.001 plus 28 times 0.001 squared. This can be calculated manually, but there's you understand, right? This one can be calculated manually. Imagine in an ancient world before calculators were born. Before calculators, this one can be calculated manually. But for now, for the sake of time, let's just use a calculator. Plus 28 times 0.001 square. I believe you will get 1.008028 approximately.
Okay.
I mean, because the approximation is because here you still have plus dot. You still have other terms, which if you substitute the x in, you will be able to obtain the actual exact answer. But here we just need an approximation. Okay. So yeah, that's the approximation already. You can double check with a calculator. What is 1.001 to the power of 8?
One 1.008.
This one, right?
Yeah.
Is it close?
Yeah.
Yes. So you learn a new technique. You learn about how ancient people expanded numbers without a calculator in the past using binomial expansion. Okay. Yeah. All right. Then homework for you is question 2. Is it too difficult? Is it too difficult? Maybe I'll start you off. I'll start you off. This one. Maybe you're not used to seeing such weird terms inside the binomial. Right. First, we got the x plus 1 over 200x squared raised to the power of 10. They want you to expand in descending powers of x. So you must start with the highest power of x. So what you do is you treat this as your A, treat that as your B, and then you expand accordingly. So you need 10 choose 0, multiply by x power something, multiply by 1 over 200x squared power something. Which power do you want to start with? Just remember, you must start off with one of them to be 0, another guy to be 10. Do you want 10 here, 0 here, or 0 here, 10 here? Descending powers.
10, then 0.
10 then 0, right? Why? Because if you tried the other way, you will get a very, very small power. Here is 1 over x squared, which is actually, maybe if I just simplify on top, 1 over 200x squared is actually just 1 over 200 times x power negative 2. If you raise this to the power of 10, what will you get? You'll get a negative 20, which is definitely not the highest term. Descending power means you must start with the highest power. So good choice, 10 on the x and then 0 on the 1 over 200x. Then what's the next term? 10 choose 1, x power, what is it?
9.
9, then 1 over 200x squared power 1, right? Because the power must add up to 10. And then they want the first 3 terms. So can you tell me the last term?
10, then 2, then x to the power of 8, then the b term to the power of 2.
Yeah, correct. Okay, then plus dot. Okay, then you want to simplify this. Anything power 0 is equal to, what is it? Anything power 0 is?
1.
Good. 10 power 0, 10 choose 0 is?
10 choose 0. Then
Then choose 0.
then choose
Think about it.
0.
Think about it intuitively. You have 10 clothes in your wardrobe. You want to choose 0 clothes. How many ways can you do that?
1.
There's only one way to choose none of the clothes, right? 0 means none of the clothes. So 1. Then x power 10 is just x power 10. So equals x power 10. Okay, good. Plus, next one. 10 choose 1. You got 10 clothes and you want to choose 1 clothes. How many ways?
10.
10 ways. 10 times x power 9. Then multiply by, wow, this is a monster. 200 x squared, right? We simplify later. Then plus 10 choose 2. This one.
10,
What's 10
10
choose 2?
choose 2. How do you how do you even think about it logically? 10 choose
Okay.
2.
10 choose 2 means you start off with a wardrobe with 10 different types of clothes. You have a bag that contains 2 spaces. How many ways can you choose 2 clothes from 10 bags? What? How do you, among the 10 clothes in the wardrobe, how can you choose 2 of them to put inside your bag? First space got 10 options because you got 10 clothes. So you put 1 shirt inside here already. Or you put 1 shirt inside already. Then after you put 1, how many is left in the wardrobe? 9. So here, the second space, you got 9 options. So is it 10 plus 9 or 10 times 9?
10 times 9.
10 times 9 possible ways. But do we care about the order that we put in?
No.
No. So you have to divide by the number of ways that you could arrange each 2 clothes you pick. So divide by 2 factorial. Does that make intuitive sense?
Sure.
And of course, you can just use a calculator. 10 choose 2, 45. You can verify 10 times 9 divided by 2 factorial is the same. Of course, if you wanted to, you can also use the n factorial over r factorial divide by n, multiply by n minus r, which is 10 minus 2, which is 8 factorial formula. That will also work. Okay. And times x power 8 times this one, 1 over 200 square, then multiply by 1 over x square square. Is this part okay?
Yeah.
Can then plus dot dot dot. Then now we try to simplify. I'll shrink this down. Okay, so yeah, just expand 10 over 200, 1 over 20. X power 9 minus 2 is 7, right? And this one is 45. 45 times 1 over 200 square. I'm just going to use my calculator straight away. So 1 over 200 square, and I get 9 over 8,000 multiplied by x power 8. Then this one, 1 over x square square is 1 over x power 4. Then I can just simplify it straight away into x power 8 minus 4, which is 4. Okay.
Okay.
Do you notice anything about the power? What's the pattern? Minus 3. 7 go to 4. Again, it's minus
Minus 3.
3. Do you think the pattern will continue?
Sure.
Yes, it will. Keep that in mind. Then next lesson, we will go through about the R plus 1 formula. I don't think I have time to go through R plus 1 formula today. Okay, so now that we got 3 terms already, maybe I'll leave that to you as an exercise. Homework.
No.
Don't want.
Nah, just kidding.
Oh, okay. Okay, then you want to evaluate 1.005 to the power of 10. But take note that over here, it's no longer the simple case of 1 plus 0.005, and therefore your x is equals to 0.005. It's no longer the case. Because if you look over here, you got x plus 1 over 200x squared. Here, it's a bit confusing. I'll let you think about it. What is 1 over 200? My hint for you is, what is 1 over 200 in decimal form? Okay, go think about it. Then go and figure out for me an approximation for this guy.
What the? Okay.
Find a value of x. I already expanded it. I did most of the work for you already. You just need to pick a correct value of x to substitute it. Okay, then just use a calculator to calculate the right hand side. All right, we'll go through it next lesson. Let me see. 28. Okay, I can go through 12 minutes. Okay, let's see the next one. Question 3. Okay. I'll send you the questions to do as homework later. I'll send you the homework later. So let's look at question 3. So in the expansion of the expression x plus 3 times x minus 2, oh my goodness, this question is difficult, times x plus 1 to the power of n. Suddenly remember, the coefficient of the quadratic term is 2. You want to find the value of n. How? So here's the strategy. When they say expansion of the expression, let's just call this f of x. They mean you need to expand the whole thing, not just the binomial power, not just x plus 1 power n. So let's expand everything. Let's focus on the ones that have no powers. So this one will be x squared plus 3 minus 2 is plus 1x minus 2 times 3 is 6 multiplied by x plus 1 power n. Then now let's focus our attention on x plus 1 power n. The question is focusing on, they gave us information about the coefficient of the quadratic term, right? Yes? So how do you get quadratic term when you multiply by a quadratic? Wouldn't it make sense if x plus 1 power n, we expand it until we get some constant plus something times x plus something times x squared plus something times x cubed. Right? The n is just an integer. Then how do we get quadratic? It's constant multiplied by quadratic. That's how we get one quadratic term, correct?
Okay.
Any other ways?
The x squared times the constant.
X squared times a constant. One last way. Linear.
Or the x times the x.
Exactly. So what does it mean? Do you actually need x cubed?
No.
Don't need, right? So you just strike it off. So what this question is implicitly asking you to do is to expand x plus 1 power n up to the first 3 terms. They are being very indirect. They want you to hint to you, you must deduce on your own. You don't need power 3 anymore. Just expand up to x squared. You must be able to deduce that on your own. So that's what we're going to do. Just treat the n as if it's a whole number. As what we've been doing so far. But now you must be more general. So let's start. Maybe I can. Okay, how do you think I want to start? How do you think I can start? I want constant first. Definitely must be n, right? Just now we have the power is always the top number. Then what's the first number you put here? Can you remember? Always start with
1.
wrong, 0. Okay, always start from 0. Multiplied by
x to the power of n.
Okay, you want n. So you mean you want to pick n and
No,
0?
I want r.
Huh?
Wait, what?
R in this case is 0. Okay. It's okay. You only have this option n0, or the other alternative would be to swap the n and 0 around, so you get 0 and n. So like this, right? Remember, you must always start with a 0, and then the sum must add up to the power. So which one will give you a constant? Option 1 or option 2?
Option 2.
Option 2, right? Because over here, option 1, you can think of n as an integer. Like for example, 5, then here will be 5. That's x power 5, definitely not a constant. So that's why we don't work with this one. Maybe I'll just purple strike off. This one should be the one we work with. Yeah, so we should have x power 0 then times 1 power n. Can you tell me what's the next term?
N.
Choose
1
times x power
1
times 1 power
times 1 power n minus 1.
Very good, n minus 1. But of course, since the question is being kind to you here, they put a 1 as the base. 1 power anything is?
1 power anything is 1.
It's just 1. So times 1, you can just throw away. Also, the question is being kind. If this was not a 1, it was a 2, you have to put down 2 power n minus 1, so on and so forth, which is even more long-winded. Yeah, it is possible. Okay, next one. So that's our purple term already, our linear term, right? X power 1. Next one will be n choose.
N choose 2, x to the
2.
power of 2, n minus 2.
1 power n minus 2. Okay, but of course 1 power n minus 2 is just 1. Okay, plus, do we need any more? Remember, do we need an x cube? We got x power, we got constant, power 1, power 2. Do we need the cube?
No.
Don't need, then we will do plus dot dot dot. Okay, to tell you that, to tell people that there are other terms. It's just that we are lazy, it's not relevant, so we don't want to write it. I know that there are other terms. It's just that I purposely don't expand it because it's not relevant. So that's why I put down the dot dot dot. Okay, so carrying on, let's just simplify this. Just now we got actual number, then we know how to expand. Like 5 choose 2, we know it's 5 times 4 over 2 factorial. But now it's in terms of n, then how? What's n choose 0? So here you must remember a few more special identities. N choose 0 for all n, right, positive integer is always equal to 1. N choose 1 is always equal to n. N choose n minus 1 is always equal to n. N choose n is always equal to 1. Do you know how I know this?
No.
Let me show you. Remember, 1 n n 1. Maybe it's better if I write it from left to right. I think you'll see the pattern more clearly.
Oh.
1 n n 1. Where do you see that? Go back to your Pascal's triangle.
Okay.
Yeah, I think you get it already. 1 n minus 1 and 1. This fella here is n choose 0, which is 6 choose 0. That fella there is 6 choose, no more space. N choose 1, which is 6 choose 1. That fellow over there is n choose n minus 1, which is 6 choose 5. That last guy over there is n choose n. In this case, it's 6 choose 6. Okay?
Okay.
And of course, if it's row 6, n equal to 6, then it will be 6. N equal to 5 is a 5. N equal to 4 is a 4. N equal to 3 is a 3. Likewise over here. That's symmetry. That's symmetry. Okay? Here and here. I think you can see a lot of patterns here. Pascal triangle got a lot of funny patterns. I can send you a video. If you're interested, you can go and watch. Some Pascal triangle tricks. Okay. Anyways, just tell you what's relevant for this question. You only need these two. You only need these two. And actually also more. Still got one more. Still got one more, which is n choose 2. It's just n times n minus 1 divided by 2 factorial. That's from the formula. So far, you have seen a lot of examples already, right? The wardrobe got 10 different shirts, then you got 2 spaces, so 10 then times 9. Here, if it's n choose 2, what it means is you start off with a wardrobe with n many different types of shirts, and then you have a bag that contains how many spaces? 2 spaces. First space got how many options? N options, right?
Yeah.
Then how about the second space? You already put one shirt, n minus 1 option. So you can have a total of how many options? N times n minus 1. But you don't care about the order, right? You put a shirt on the left and you put another shirt on the right. Versus you swap the position. It doesn't matter. Then you just divide by 2 factorial to get the unique combinations. That's how you get this formula here. N times n minus 1 over 2. So likewise, you can replace all these n choose 0, n choose 1, n choose 2 with 1, n, and n times n minus 1 over 2 factorial. Is that clear?
Okay.
Can Then you just fill in the rest. This one it's just a 1. Correct or not? Anything power 0 is 1. 1 power anything is 1. So it's just 1 times 1, which is just a 1. Here you got plus n times x, which is plus nx. Here you got x squared times 1, which is just x squared. I'll just simplify it as n times n minus 1 over 2 x squared plus dot 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 plus dot dot dot. Is this part okay?
Yeah.
Okay, good. Then what did they tell us? Okay, they tell us that the expansion of f of x, which is x squared plus x minus 6 multiplied by x plus 1 over n, power n, will give us the coefficient of the quadratic term to be 2. What that means is we now have to substitute the x plus 1 power n, which we have found over here, back inside, which means that we will obtain f of x equals to, I'm just going to rewrite it, f of x equals to x squared plus x minus 6 multiplied by 1 plus nx plus n times n minus 1 over 2x squared plus dot dot dot. Okay?
Okay.
So far so clear? Okay, good. Now you want to get the quadratic term. How? Follow the arrow. Green, purple, yellow. I'm just gonna do it here. So green, purple, yellow. Okay, then you expand. So you get, you don't care about all the other terms, dot dot dot, plus dot dot dot. There's all the constant terms, linear terms, power 0, power 1. There's all the power 3 terms. We don't care. We don't care about them. We only focus on the quadratic term, which is relevant to the question. So that's what we're going to do. We're going to get the quadratic term. So x squared times 1, 1x squared. Color code in green. Then purple, x times plus nx, what do you get?
X times nx squared.
Nx squared, purple. Next one, yellow, negative 6 times this. 6 and 2 cancel off, you're left with 3, negative 3. So negative 3n n minus 1 multiplied by x squared. That's the yellow one. Is that clear?
Yeah.
Then you combine them together, dot dot dot, plus 1 plus n plus negative 3n minus 3n bracket n minus 1. This is the coefficient of x squared. Does that make sense?
Yeah.
Then what did they tell you about the coefficient? Coefficient of quadratic is equal to?
Coefficient of quadratic is equal to
Quadratic term is from the question. Question 3.
2.
2. Right. You are the comparing coefficients that you did in partial fractions. So it's the same thing. You just copy and paste this. Equals to 2. I think you know how to solve already.
Okay.
And okay. Yeah. Just solve it for you lah. Okay. At least finish up one question. 3n squared. Then this one becomes plus 3n equals 2. Minus 3n squared plus n plus 4n plus 3n becomes 4n plus 1 equals 2. Cancel off the 2, you get minus 1. I don't like negative, so I'm going to multiply throughout by negative 1. 3n squared plus 4n plus 1 equals to 0. I did a bit fast. I hope I'm not wrong. Yep, okay, that's fine. Then you can factorize 3n here, or just use a calculator. I believe you'll get minus 1 minus 1. No, plus 1 plus 1. Yes?
Okay.
Did I do something wrongly? It shouldn't be a plus 1, it should be a minus 1. Let me double check. Plus 3n. Something is wrong. Did I set the question wrongly? Oh, right. Here should be a plus. Sorry. Plus and minus. Okay, so it should be minus minus. Is that better? Is this correct?
Sure.
Can Okay, good. So that means I can now get my two answers. N equals to 1 over 3 or n equals to 1. This we have to reject. Why? Because n is positive integer only.
Okay.
In a syllables, you cannot have a non-positive integer. So that means n equal to 1. So if you actually tikam and you start from the beginning, you think, oh, maybe n is equal to 1. Then you just directly substitute x plus 3 times x minus 2 times x plus 1 to the power of 1. And then you expand the whole thing. And then you get the quadratic something x squared. And if you check that it is equal to 2, then it means that your answer n equal to 1 is correct already. You could also do that, but
Wow.
that will be very difficult. You won't know that n is equal to 1. So you should do it in general, which is whatever I show you. Okay, then your homework will be question 4 and try question 5 on your own. Think about it. Okay. And maybe
Okay.
I'll give you extra questions. I'll list down the questions you should do. Okay. That will
Okay,
be
my
all for
brain's
today.
not working.
Yeah, binomial expansion, way more difficult than partial fractions. Okay. For beginners. Yeah. All right, that's all for today.
Okay.
Any questions? No? Okay.
No,
Can.
thanks.
Okay. Thanks.